All right, everybody, we are going to start wrapping up with this last session. This is one that you won't want to miss. Thanks so much for sticking with us throughout today. Super excited for this next session, which is centered around scaling smart, so vertical versus horizontal scaling. There will be a Q&A portion, so definitely queue up your questions, and let's keep the energy high as we kind of close out the day together. With that, I'd like to welcome Ratika Gandhi.
Hello, everyone. Can you all hear me? Okay, perfect. Because um, one of the biggest perks of my job at MongoDB is that I get to talk to a lot of developers. And a lot of developers, sometimes are building apps that are just starting out. They're working on a nice new venture, or those that are building enterprise-grade applications. One of the things that is common between them that we will focus on today is that they're all worried about how their databases will scale when the time comes. The new developers are worried about what happens if their app is an overnight success. Will the database be able to handle the volume of reads and writes? And the enterprise level developers are worried about what happens when a whole new game launches and there's a million more users on their website. Hi everyone, I'm Ratika Gandhi. I'm a lead product manager of core database at MongoDB and core database and migration tools. And today we'll talk about how you can leverage MongoDB to scale vertically and horizontally. Let's dive in. So we'll talk about why databases scale, obviously, what are the scaling strategies at your disposal. Then we'll get into a Q&A, and then we'll have a quick fireside chat with Rishikesh at Infosys. Cool, so why do databases scale? Databases scale because you have a good thing happening for your application, which is you're having more and more users, more and more reads, and more writes. So if you have a CPU-intensive application where you're doing a bunch of complex aggregations, the more users you have, the more you will need to use CPU. So your CPU usage will go from 2 vCPUs to 4 to 8, and so on and so forth. The next common reason to scale is RAM. At MongoDB, we recommend that you have your most frequently accessed documents and your indexes in RAM so that you don't have to make the trip to the disk and you can have fast queries. The more data you store, the more RAM you need because your frequently accessed data is more and your indexes are larger. So that's another reason to scale. The third reason is if your app is doing a lot of concurrent operations, your disk better keep up with it. So that's another reason to scale because you want more disk I/O. And the last reason is the most intuitive of all. You just were storing a terabyte of data, but now you have to store 10 terabytes. So you need a bigger disk, and therefore you need to scale. So what are the existing scaling strategies at MongoDB? We'll start with the simpler one, which is vertical scaling. All it means is you started on a machine of a certain size, and now because your reads and writes are growing, you want an even bigger machine. And now your app is popular overnight, everybody wants to use it, so now you want an even bigger machine. So you keep scaling vertically. If you're using Atlas, you just go on to the next tier. If you're using your own machines on-prem, you just move to a bigger bare metal machine, or you add more resources to your VMs. So this is the Atlas Cluster Builder UI, and here you'll see that we offer a bunch of different tiers. Every tier has double the CPU, double the RAM, and double the storage. And you can choose a tier of your choice. You can start at an M30 and slowly grow up, or you can let us do that work for you, where you can just click a button called auto scaling, and we'll scale up. We'll decide, hey, your application has been bombarding the system for a while now, so I better scale up so that you're prepared for this burst. And after we scale up and we realize that, okay, your application burst is over, we'll scale you back down to save your costs. So we can do that for you, and we do the same for storage scaling as well. Vertical scaling, as you can imagine, is very easy to implement and easy to manage. Just a click of a button and you're sorted. You don't have to really make any application changes. You definitely don't have to think about your architectural design. So what are the disadvantages of vertical scaling? Why doesn't the whole world just keep using that? As you can imagine, there's physical limits to a hardware. So it offers nonlinear scaling in terms of cost. You keep paying more and more for your resources, but you don't always get 2x, 4x, 8x performance for that cost. It's not cost efficient at scale. You're better off using commodity hardware instead of a custom hardware that you will have to build for the scale that you want to operate a machine at. And then, like I said before, like you could hit a hard cap and a machine bigger than that just doesn't exist. Of course, all of this means that your workload will be all competing for the same resources. There'll be no isolation for the workload on these machines. So what do you do if you're in such a situation? You can leverage a technology called horizontal scaling. We call it sharding at MongoDB. Basically, sharding is nothing but a cluster of machines running on the same cluster. As you can see here, you can scale sharding infinitely. You can keep adding more shards, more commodity hardware as you require it. And in Atlas, we give you a very easy option. You click a button, say I want to shard my cluster, and then we let you choose a number of shards that you want to start with or that you want to move to. If you're a replica set, you move to a one shard cluster first, make sure you're fine and comfortable on this new architecture, and then you can add more shards. So what are the advantages of horizontal scaling? You get more bang for your buck. You have predictable cost scaling. You have, it's at scale, like if you're running a 50 shard cluster, a 100 shard cluster, a 200 shard cluster, if you're a big bank, then it's better off to run it on commodity hardware at that scale as opposed to the custom hardware that you'll have to pay through your nose for. And you have more granular control on each shard and its size, so that helps you effectively scale with cost as well. And there's more fault tolerance. However, all of this comes with increased complexity. So you have more components in a sharded cluster. You have a MongoOS, which is a router that tells you which shard your data lives on. You have config servers that maintain that metadata map. It's more complex and therefore harder to manage. You have to think about, hey, how will I partition my data? I have all of these SSN records, for example. At what point do I partition them? You have to make code changes in a lot of cases to make sure your data scales, because you did not start off with scale in mind. And then troubleshooting obviously is more complex, the more components you add to a system. So when do you choose horizontal scaling? You choose it when you run out of a single machine's data size. You choose it when you have an application that requires a lot of high performance. And of course, for cost effectiveness, when there's you have many collections that are highly concurrently accessed, you're better off isolating them so that you're not competing for the same resources. That's also another way to leverage horizontal scalability. And then workload isolation and global deployment. So if you have a regulatory or a compliance requirement to have certain data sets in certain regions, sharding is your best bet. You can have multiple shards across the globe with one single endpoint. So you don't have to worry about doing any application level routing. So at MongoDB, we have two horizontal scaling strategies. Prior to 8.0, we only had one. The second one required you to do a bunch of voodoo. But in 8.0, we made it very simple to leverage horizontal scaling in two different ways. The first one is the new way, which is moving collections. All you can do is add a second machine and you move your unsharded collection to that second machine. If you have another hot unsharded collection, you move that to the third machine, and so on and so forth. And the second strategy is to shard your collection, which is the traditional partition a big data set into multiple different partitions, and each machine has a part of your data, and therefore the part of that index, of those indexes. So let's dive into each of these options. Moving collections, we can work best with an example. Here we have a shard 0, which has a riders collection and a drivers collection. Over time, you realize that both of them are growing pretty fast. This is a brand new market that you're tapping into. People are okay to go into strangers' car for a short ride, and your database is growing pretty fast. So, but you're not ready to shard yet because that requires you to think too much and you want instant scale. What do you do in that case? In that case, you simply run move collection. So you say move taxi.drivers to the new shard that I just added called shard1. And what we do in the background is we rewrite your drivers collection onto the shard1 while you're still writing onto the drivers collection on shard0. So it's a fully online operation. You don't have to worry about making any changes, and we manage the cutover for you. After the collection has been moved to shard1, we drop the collection from shard0. And you have instant scale right there. Let's look at a more complex example. Say here you have a bunch of uncharted collections on shard0. Collection E is growing more than the other collections are growing. So you add a second shard, which is a bigger shard, which is now possible in Atlas. It's been a feature we introduced last year. It's called independent shard scaling. So you add a bigger shard onto your same cluster and you move collection E to it. Again, we'll rewrite it on shard1, drop it from shard0 while you're still able to run your application with no downtime. And then you decide that, hey, I want collection F to be isolated too because I have a very sensitive tenant whose data I'm managing in F, and therefore I need it to have its own resources because they're paying me a lot of money. So you move F there. Over time you realize, and that's the beauty of MongoDB because it's so flexible, that you want to do cross-shard transactions between E and H collection. So in order to minimize the network latency, in order to keep it very efficient, you move collection H to shard1 also. And you probably scale it up even more if you'd like. And this way you can leverage move collection without making any application changes to manage, to get instant scale for your databases. So it's pretty fast. I can quote some numbers, but it depends on the number of indexes and number of documents you have, but it's extremely fast. We have no impact because you're still writing to your original collection. And lastly, you don't have to make any application changes. So when should you use move collections? You should use move collections when you don't want to make any application changes just yet, when you want to isolate certain collections, you want independent scaling, like I mentioned. So if you're using Terraform, if you're using Atlas CLI, then you have an option of having asymmetric shards in Atlas. So you can have an M40 shard with an M80 shard in the same cluster. So that's when you could leverage move collections as well. Or if you've sharded a bunch of collections, but you have a bunch of unsharded collections on a single primary shard, today you can move it around. You can isolate fault, it helps you improve resilience, and you can have shard per tenant or shard per database. So if you're onboarding a whole new tenant, you don't need to worry about adding more load to the same shard. You can add a new shard and onboard the tenant there. And then, using this, you can strategically co-locate your collections to a shard of your choice. So now, let's talk about sharding collections. How does sharding collections work? This has been a feature that has been around at MongoDB for years and years. It's a native MongoDB feature. For every collection that you would like to shard, the main thing that you need to decide on is that what you will partition it on, whether you'll partition it on _ID hashed, whether you'll partition it on a compound key, or you'll partition it on driver's ID or rider's ID or zip code or location. There's a lot of options, but essentially a key in your document, a key that exists in all of your documents in the collection, you pick that and we partition the data on it. Preferably a key that makes you have more targeted queries, as many as possible for your business critical queries. And then you have to do this work, which is required in a lot of cases where you'll have to pass in your shard key so that the MongoOS knows where to send your query. So MongoOS just maintains a map of which shard key lives in which shard. If a query doesn't have a shard key, then the MongoOS will just send your query to every shard in the cluster and wait for a response back. But if your query has a shard key, then I know exactly where to go. So it'll be a very quick, targeted query. That's why you often want to change your application. So how do you go about selecting your shard key? It is heavily dependent on the queries that you have. So we made it pretty simple for you. We have a configure query analyzer command that lets you sample a bunch of queries in the background. So you run it and we'll sample 5 queries per second, for example. And we'll use that queries that we sample. We'll keep the filter of each query in mind when we're doing the analysis for the shard key. Then you run analyze shard key. Analyze shard key basically is like, for this collection, for this key, tell me how my shard key performs. And by that, we mean, give me the characteristics of my shard key. Tell me whether it's monotonic or not. Tell me whether it has high cardinality so that when I actually shard on this particular key, my reads and my writes will be spread across all of my shards. If it's unique, you have to bake that into your shard key. And preferably, it shouldn't be highly frequent because you don't want to create any hotspots of your data. Then we go into read and write distribution. This is where we need you to tell us which queries you're running in the background. This is why we ask you to sample queries. Because say you're running all of your queries on driver's ID. All you do is find by driver's ID, update by driver's ID, delete by driver's ID. Then your percentage of targeted reads and percentage of targeted writes will be 100%. But say you don't do that. Say every query uses a whole different field, which is not driver's ID. Then your percentage of scatter gather reads and scatter gather writes, which is when MongoOS will send the request to every shard in the cluster because it doesn't know where the data lives, that will be 100%. So you want to optimize for more targeted reads for a more performant application. We also go into more details like which reads and writes are multi-shard, how many times are you changing your own shard key, which is an internal transaction, so is slower, so you should be aware of that, and percentage of writes without your shard key. So here is a quick example. If you were first querying by just username the taxi driver, and you decide to shard on location, in order to have a targeted query, you'll have to change your application to do a location, find by location, and find by username. And the same for another example, if you're doing a $set of the last drive timestamp by the username, now you need to add in the location to perform a targeted query. Not that the other queries will not work, they will work, they will just take longer. So if you have latency sensitive queries, you have to make these app changes. So sharding a collection again from a operational perspective is essentially run shard collection taxi.driver and give us the key you want to shard on. So here you're saying, hey, shard it on taxi.riders, and here you're saying shard it on riders ID. Great. So now there's two ways. The balancer will be like, okay, you want me to shard on riders ID? I will go figure out how to partition your data such that at the end of the balancing round, you have equally sized shard. So that means, and that's a proxy for your reads and writes. So our aim is to give you a balanced read and write load on each shard. You could do that, or you could do something smarter, which is the whole reshard to the same shard key that we've introduced in 8.0. Essentially, rewrite your data on both the shards and drop the old collection. So you don't have to deal with orphans, but you achieve balanced state at the end in a lot faster manner. If our recommendation generally is that you do move collection for your scaling, but in some cases, move collection is not sufficient. So in those cases, which are like, if it's too large, then I can't really move it to a bigger machine because it doesn't exist. Or if it's too hot, I definitely need to break it down so that I can divide my read and write load amongst the number of shards in the cluster. So basically, all 8.0 Plus has done for us is made it possible for you to be really flexible, really limitless, and like have limitless growth with MongoDB sharding. So this is a quick example, and we'll sum up right after this. There's a collection here. There's 3 collections on shard 0, voucher, drivers, and riders. And over time you realize, okay, drivers and riders are growing and I would like to shard one of them. You pick on riders because you have a bunch of riders on your application now. And you do shard collection, taxi.riders, and then you shard on rider ID. You wait for this sharding to complete, and then you decide that you also want to shard drivers. So you run another shard collection, taxi.drivers, and driver's ID. And we balance it for you in the background. For voucher, you're like, it's eating up the same resources at shard 0, but I'm not ready to shard yet because how much will my voucher collection eventually grow anyway? So you just add a third shard and move the voucher collection to the third shard. And that is again, move collection, shard 2. So now you have achieved a perfect scalable solution for your application at that point in time. Sharding is often perceived as a very complex decision, a very one-way door, when it isn't. Like since 5.0, we allow you to change your shard key simply by running reshard collection, and we do a whole online operation to change your shard key. And in 8.0, we take it a step further by allowing you to unshard a collection. So if you've sharded a collection, we can unshard it for you. All you have to do is tell us which collection to unshard and which shard to put the unsharded collection on. And we'll rewrite it in the background and mark it as unsharded, and it will be as good as you never sharded that collection. So now sharding offers a lot of these kinds of flexibility. So in the end, like this is what I want to this is what I want you to take away from this session, which is typically people hesitate to start with a one-shard cluster. But if you're building for scale, it's best to start with a one-shard cluster. Not yet worry about all the application changes you'll have to make, because you can still leverage vertical scaling on a one-shard cluster, which is easier to manage. You don't need to make any application changes. And it also gives you the flexibility to add more shards as you'd like by just simply using move collections. But if you grow beyond a certain size, now at that size, you're not worried about converting from one type of topology to the other type of topology. At that size, you're already prepared for it. And all you need to do is find your shard key. So for large data sets, for isolating workloads, and for cost efficiency at very large scale, horizontal scaling has got your back. And with that, I'd like to open up for some questions right now because we have the time. And then we'll dive into a fireside chat with Infosys on how they manage these questions. Oh, my headphones.
Hello,
Okay.
can you hear me?
Yeah, I can.
Okay, wonderful. Quick question. When I want to do this sharding, do I need to take database downtime?
No, you don't need to take database downtime. So if you're moving from a replica set to a one-shard cluster, then Atlas basically manages your connection string for you. So it's a completely online operation onto a one-shard. And we recommend that you change your connection string as soon as you're onto the new configuration, not connection string, sorry. You restart your application once on your app servers, and a lot of customers do it in a rolling fashion. So what that means is now your application will start connecting to the MongoS instead of MongoDB. And so the rolling app restart is all you need to do to convert from a replica set to a one-shot cluster.
Okay. So that is, say, my application has millions of records, and it is also writing millions of records on a daily basis. So I can do this sharding from one single shard cluster in a real time without having any downtime.
Correct, yeah, like there's two ways. I thought you were, say you were on a replica set where you don't have MongoS or config server at all. You want to move to an architecture that lets you add more shards.
Correct.
So this operation is online. You just need to restart your app servers to connect to the MongoS. And you can do that in a rolling fashion at your own time. Preferably as soon as you get to this architecture. And then when you add more shards and you shard a collection, that operation is also a fully online operation, because we will take care of the data movement in the background for you. whichever way you choose to do. If you choose to do it with balancer, great. If you choose to rewrite the data, great. But all of that is an online operation.
Okay. So what I'm not clear is, will the application need a downtime
No,
still?
no,
need.
it's
Okay.
not. Like that's what I mean by an online operation. Your application will not need any downtime. When you run the shard collection command, it's an online operation. We just give an indication to the balancer in the background saying that now you can start balancing this collection, and it does that all in the background while you're still reading and writing from your application like nothing changed.
Thank you.
Hello. I know the one of the key factor for the sharding is the horizontal scaling, but other than the horizontal scaling, is the requirement if you having a multiple active primaries, I mean if you have to list out why the application needs to go for a sharding, if you have to list out top three reasons, right?
Yeah.
So what would they be?
Yeah, I think the top three reasons, this will take me a while, is basically you have too large of a data set, and this is actually, I'll give you top six. You have too large of a data set, and that is not able to fit on a single machine. You have, let me just not worry about this, hold on. I thought I'll get there quickly, but yeah. So large data sets, you have nowhere to go. You have to partition your data. And by active primaries, sharding a collection, all it does is, if you have a terabyte of data on one shard, you add two shards to your cluster. So there'll be 333 gigabytes of data on each shard. And all of those shards have their own primary and their own secondaries. So you are writing to your application like nothing changed, but now your writes are going across 3 machines. So you can scale like that. So these are all active primaries. It's not an active architecture. That's a different architecture. But if you have very large data sets, and if you have collections that require its own like high concurrent usage, if you have like millions of operations going to the same machine all the time, you're constantly fighting for the same resources. It's better off to like send a million operations to 3 shards as opposed to 1 shard.
Yeah, but what's the limitation? I know, as per the books and the documentation, right? So the anything close to 2 terabytes or 1.5 terabyte, it's the time for the sharding, right?
Yeah.
Converting to sharding. But look at the the current the DNA of the storing the data and all volumes, right? So isn't it 1.2, 1.5 or 1 terabyte is too less? And then why is that the cap at that 1.5? What happens if we go continue to be host more data into it? What are all the challenges?
So there's not like you can totally do that. And when we say 1.5 to 2 terabytes, we mean compressed data size. So depending on your compression ratio, it's quite a bigger collection. The downsides is generally what happens is, if you're thinking of scaling horizontally, you have to start thinking about how you would have to change your application, if at all. If you're thinking about at 10 terabytes or 12 terabytes, then you're just racing against time. You're much better off if you're on-prem and you have a hardware that is like allowing you to write hundreds of terabytes into it, and it's still making sense for your latencies and throughput, great. But if you're on a hosted machine where you have data size limitations, then that's where the recommendation comes from. You're better off thinking about it at an early stage than at a later stage, where the rewriting will be a lot of work, the balancing will leave behind a lot of orphans, and it's just preparing you for scale much ahead of time than later.
Yeah. So we have one application where we have close to 10 terabytes of the compressed data, and it is running on the replica set. And then I know the moving on to the sharding, So we are talking about the 5 shards, or it's an expensive solution, right?
Right.
So and on top of it, okay, you have two options: whether to go with the sharding or be on the replica set.
Right.
Because we're able to store, but the challenge is becoming is with the backups,
Correct.
right?
Yeah.
The
The RPO and RTO would be
yeah,
slower.
yeah. So for those type of solutions, do you have any options? Any solutions? Without moving to sharding and then not willing to really spend on the huge infrastructure.
Yeah, like the bigger file you have, the longer time it will take for us to restore your backup, and that will impact your SLAs, right? So there's no magic solution to this other than the fact that you have to shard at that point. Um, in terms of cheaper, like that's why we've introduced independent shard scaling. That's why we've introduced embedded config servers. All of this like make it easier for you to have hardware of your choice into the cluster, as opposed to the previous state where if you had an M200 replica set, then all of your shards had to be M200. So like there's ways to reduce cost there, but at the end of the day, you are storing a large amount of data, and so you have to basically like prepare for it. And what typically I recommend is, if you're using an M200 replica set, add 5 shards and then scale down. So like scale down to an M50 or scale down to an M60, and then like do a cost analysis. It'll still be more than a single replica set if you're going to 5 shards, but it'll not be a whole lot more if you divided your operations across multiple machines. So you won't need that much more CPU, that much more RAM per machine.
Thank you.
Yeah.
Appreciate it.
Yeah. Okay, one last one.
Hi, thank you for the session. So when in that moving collection, when it is moved to a new shard, I hope all the indexes are preserved. So is there any cold start problem, or does it need any warm up?
No. So essentially what we do is we rewrite your collection. We first clone it, then we'll build all of the indexes on it. Then while all this is happening, we are buffering the oplog. So when you're writing to the original collection, we'll obviously let you write that, but we're also buffering those in a separate collection. Once I've cloned your data, once I build all the indexes on it, then I will apply all the oplogs on it. So at the end of it, like at the cutover, both your original collection and this new collection are in the exact same state, and they have the same data. And then I do a cutover. And so in this process, you don't have to like worry about cold start or anything, because we already do like mirrored reads on Atlas, etc. by default. So your MongoOS knows that this is where your data now lives. So it'll just start sending the data to the newer shard. Yeah.
Thank you. Other question is, let's say I have two, let's say collection A and B, both reside in the same shard. Now let's say B is moved to a different one. If I have a union between the two collections, do you see any bottleneck going?
Okay. Don't do that. Okay. Move both the collections together, because like anytime that you have to go to 2 different shards, you're basically at the mercy of the network latency, and you have to like if you're doing transactions, for example, you have to deal with 2-phase commit also. Again, I have to go to 2 shards, talk to them, wait for the responses back, and then give you a coherent response, right? So typically, if you have that kind of a use case, you're better off keeping both the collections in the same shard. If they're growing a certain size and you have to shard them, then that's like something I would love to talk to you more about, because it's a feature I'm evaluating.
Sure.
Where you can use zones to keep the same, like if you say everything on both the collections is driver's ID, but you just have to do a union on both the collection, right? Using the same shard key. Then you can use zones to co-locate same shard key for both the collections on the same shard, so that your documents that you're accessing together are always at the same, on the same machine. So that's another solution that you could use.
Thank you.
Okay. I'm going to be around for more Q&A, but I do want to invite Rishikesh from Infosys for a quick fireside chat. He is an engagement manager and is working on the app modernization practice. So let's see what he has to say about all the scaling deep dive that we just did. Hi Rishikesh, welcome.
Hey, hi Ratika. Thank you so much for a very engaging and informative session. So I would definitely like to, I learned a lot, but I would certainly like to know more about sharding, scaling, horizontal, vertical,
sure.
yeah, anything, yeah, certainly, yeah.
Anytime. Rishikesh, do you want to start with a quick intro for everybody?
Yeah, sure. Okay, so I am Rishikesh. I come from the application modernization practice at Infosys. So, as the name suggests, we help our clients in modernizing their applications. So, we help our clients in getting out of legacy mainframes, helping them reducing their tech debt and stuff. One of the important patterns or one of the important initiatives that we have with our clients is database modernization and migration. So that's where the partnership with MongoDB comes into the picture. So we have a lot of clients where they have implemented MongoDB or are in the process of doing so. That's where concepts like sharding, scaling are going to come into the picture. So as I said, I learned a lot, but I would certainly like to know more and use that information and insight into discussions with our clients.
Yeah, I'm happy to talk to you at any
Oh,
point.
absolutely, yeah.
So what did you think of this session? Do you have anything else to add?
So as I said, it's very informative. So, and for sure, what I would want to do is that have my architects and engineers engage at very early in the entire journey when they're looking at moving to modernizing their databases and moving to MongoDB. So these are some of the concepts at the architectural level itself that they should be looking to keep in mind, and it should be there at the top of their consideration list.
Okay, got it. So in your day-to-day role, Rishikesh, based on your Infosys client base, what are the common signs you see in a business growth that warrant scaling discussions?
Okay, interesting question. So as I said, right, so I am from the application modernization practice. So we do encounter a lot of these discussions where clients are talking about, not just the database layer, but overall at the, the application modernization also. So whenever you have, whenever you have the database that is getting any kind of change, not just any kind of a migration or a modernization that takes place at the database layer, even the application layer gets impacted, right? And so what happens is that because the application layer is getting impacted, there will be changes in patterns on how that application is getting consumed by the end customer, right? So you talked about new games getting launched, and you talked about new apps getting launched. So that's and suddenly there will be a surge of traffic. That's a very good problem to have, but you have to solve for it, right? And that solving for that problem should be right at the time when you're conceptualizing the entire architecture itself, right? So to answer your question, so in my opinion, right, whenever you have any modernization happening because the application is also getting changed, the business pattern in how the users were interacting with that application changes, and that in our in my experience we have seen that changes or that surges the demand on the application from the user side more often than not. Okay, let me put it that way. So if you are, as I said, right, if you are able to use all of these strategies right at the conceptual level itself, that will certainly help. And those are the typical use cases. Whenever there is a change in the business pattern, anything new that is coming in, those are the typical kind of, clients that you would, maybe use these strategies for.
So it's not just about modernizing their database, but it's also about thinking about what were the earlier bottlenecks and then re-architecting it in a future-proof.
Absolutely. Okay. And you will have those changes that, because as I said, the consumption pattern itself will change. Because consumption patterns are changing, that you will see those sudden spurts. So you have to plan for that.
Okay. But why would the consumption patterns change?
So as I said, right, so because there was a pattern, there was a way in which the application was being used earlier. Now maybe there's a change in the business demand itself, the way that the users are interacting with the new application, that changes. And you always, you modernize or change for the better, expecting more traffic to come in. That's where, these scaling will definitely come into.
Okay, got it. And I have to ask you this because you interact with a bunch of customers and suggest where MongoDB is useful. So, how can our flexible scaling options help customer future-proof their technology? And if you have any feedback for us, we'd be happy to talk about that too.
So Ratika, so this we talked about moving collections. So that's something that I found really interesting, because especially some gentleman was asking you a question and you said you don't have to have any downtime at all, right? Right. So that's something very interesting, right? While you are scaling, there is no downtime at all. Plus, on top of that, there is that element of you, again, in your answer itself, you said there is that element of cost-benefit analysis that also is baked right in.
Yeah.
So it's not a blind scaling that you're doing. It's a very conscious decision that you are taking. So this moving collection feature that you talked about, right? I think that really addresses that point very well. Yeah.
Okay, cool. Yeah, I hope like the Unshard and the Reshard also helps people.
Yeah,
not
exactly.
be,
Yeah,
like,
absolutely.
completely scared
Absolutely.
about making a
Exactly,
big choice.
exactly.
in their
So
database.
you said that we can unshard you were you to feel that this is not solving your. So that's a very unique feature, right? I mean, so that's something that's definitely a very useful feature in MongoDB for sure.
Yeah, thank you so much.
Oh, absolutely.
Anything else you'd like to add for the audience for the AMP practice?
No, so I mean, so I hope everybody had a great .local event, and as I said, I learned a lot right from the keynote address in the morning and all the way for all the different sessions. So yeah, it's a good event to be at. Yes, definitely.
Awesome. Yeah.
Yep.
Thank you for being a great partner and
Oh, yes.
keep recommending MongoDB
Oh, yes.
and telling us where
Oh,
we
yes.
need to make changes.
Oh yes.
Yeah.
Yes.
So we'll take some more questions if anybody has them. I'm still around.
Okay.
Yeah.
Thank you.
Nice to
Thank
meet
you.
I'll